Okay, so today we're going to be doing LeetCode question 39, combination sum. So for this question, we are given an array of distinct integers called candidates and a target integer named target, returning a list of all unique combinations of candidates for the chosen number summed to target. So you may return the combination in any order. So next it's saying the same number may be chosen from candidates an unlimited number of times. Two combinations are unique and the frequency of at least one of the chosen numbers are different. So what's saying is it's mentioning they want unique combinations. So like in example 1, our candidate array is equal to 2, 3, 6, 7, and our target is 7, right? So here's some outputs of numbers that are grouped up together to get our target, right? For the output 2, 2, 3, right? This equals up to 7. 2 plus 2 is 4, 4 plus 3 is 7. But if we were to reverse these numbers, so instead of 2, 2, 3, let's say it was 2, 3, 2, this isn't unique because these numbers are the same exact numbers, just rearranged differently. This does not work, right? So this is basically what it's saying here, and it's that problem in particular that makes this so tricky. And not only is that, but and it can be any length. So in example 2, you have 2, 2, 2, 2, which tries 4 times, well, the rest of them are 3 and 2 times. So 3 numbers added here and 2 numbers added here, right? So with this information, the first thing that probably comes into mind is depth first search, which basically you are traversing through an entirety of a list all the way down before going back up. And yes, we are going to have to be using a form of recursion in order to answer this question. However, because we want unique, right, unique combinations, this is not going to work because depth first search is actually going to give you the same numbers, but a little bit skewed. So we need to figure out a way or a pattern that does exactly what depth first search does, but isn't going to get the 2, 2, 3. And what that is going to be called is called backtracking, right? So that's what we're going to be using to answer this question. And all backtracking is basically like recursion, right? Depth first search, but unique numbers, right? So you're not going to go and have, this 2, 2, 3. There's specific rules and conditions that backtracking basically allows us to do. So similar to depth first search, it's very straightforward. We're going to go and create a demonstration here, right? So 2, 3, 6, 7, right? And let's say we start at 2, right? At 2, blah, 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 and this is empty, right? Because this will go through the entirety later on. So with 2, right, we are going to break this down, and we are going to have 2, 2 here. So all the numbers going to the left are going to have 2, 2, and 3, 6, and 7, right? And then this will now only have 1, 2, right? So what this segment is going to lead to is there will only be one instances of 2 moving forward going down. So you could see how this is already setting up the rules and conditions to not have duplicates. So now we will have all these will have 2 2s. I know that's a little bit confusing, but you see now we have 3. And this will drop down. So now this is another rule where moving forward, you're only going to have 2 2s, right? And this will break down into 2, 2, 3. This will also break down to 2, 2 again, because instead of 3, you are going to break you down into 2, 2, 6, and 2, 2, 7. Like that, my bad. Right? This is not going to add. This will be greater. So we can X these out. And we know that this is correct, right? So this is one of the answers. And actually, before we continue to explaining, because I low-key kind of messed it up. Oh, sorry. 2, 2 again, and then here, right? So taking a break or a second to take a look at what we just wrote, you kind of see how there's rules set in place, right? So you start at 2 here, and you have the condition, okay, so each number is going to have 2 sets of 2, right? As you can see, each one has 2 sets of 2, and the rules continue. This has 2 sets of 2, or this has 3 sets of 2, right? And this will be broken down later, you know, to 2, 2, 2, like 3, right? This wouldn't work, 2, 4, 5, 6, 7, 8, 9. So this will get an X. But as you can see, basically just rules and conditions that you won't see this number anywhere else, right? Because the 3 is only going to happen here. Now you branch out, right? And then you can see how 2, 2, 3, right? This is the only time you're going to have these numbers in this exact sequence, because the rules going down separate them into specific sets, right? So, and then we're backtracking. And this applies to every single number. We're not going to sit here and draw the entirety of this search because that will take forever. But this is basically the premise of what's happening. We can kind of go over here a little bit just to finish it up. But you see how this condition is only going to have 1, 2, right? So similarly, you're going to break down to 2, right? 3, right? This will break down into 2 again, right? And then the 2, 3 will later break up to 2, 3, 6, right? And then you can do it again, you know, it's like 2, 3, 7, right? Because we're not using 2 versions of 2 with this. And like this obviously can break down into a bajillion different things. These won't work because they're too high. And yeah, so now as we have an idea, we've learned some base cases that we already need to focus on, which whether the number's too high than the target, right, cross them out. And we need to use the backtracking technique. So how that's going to look is, first things first, looking at our output, you're going to have 2 arrays, one holding all the answers inside and one storing each value. So you're going to have 2 arrays here, like so, right? And then we are going to go and grab the length. We're going to grab the length of our numbers, right? So this is the length of our list, right? And then also to make things easier, we are going to, I like to visualize what we're working with. So candidates is going to equal to 2, 3, 6, 7, right? And our target is equal to 7. There you go. And with that, now we needed to create a function for backtracking. So we will literally just call it backtrack. And we're going to need to plug in 2 values. We'll name them I and current sum, right? And let's actually call this function plug in our value so we could already kind of visualize. They will be 0 and 0. There you go. There you go. Okay. Now we need to create our edge cases, right? We already mentioned that if current underscore sum equals our target, this means we've found an answer. And because we found an answer, then we're going to need to append those values into results, right? And solution is going to be where we're storing. It's the array inside, right? And we want everything, so we do oh my god, I'm blanking. What is this called? When you have your beginning and ending value, this basically adds everything. Damn, I don't remember the vocab word. It's okay. And then we're just going to return because we're done with that. And then we need another edge case, which is if current underscore sum is greater than target, which we mentioned previously, or, right, if I equals the length of n, because the I is starting at 0, we're going to be going through the length, right? If we hit the entirety of the length, then we don't want that anymore. We're going to return as well, right? And then obviously we're going to want to call this. Each iteration, we're going to add I by 1. and you're going to pass current sum because we need to pass it because it's one of the parameters. Beautiful. So this is basically just simple recursion, right? What we really need to do is do the method for backtracking, and it's basically backtracking. It's just like a three-line method, right? Where you're going to first add values into solution, and we're going to add candidates at index I, right? Beautiful. And then we are going to call the backtracking function again, right? Where we're going to pass I, and we're going to pass current sum. Oh, that's not how you spell that. Current sum plus candidates at index I, right? Then we're going to pop. And the popping is basically what allows us to keep these unique values, or basically all this right here. We already called backtrack, so I think the only thing we need to do is actually just return result, and this should be okay. That is telling me there's something wrong. Oh, I lied to you. Let's triple check. All the conditions are met, and they are. Beautiful. Okay. So just to recap, a lot of stuff to go over. We are using backtracking. Backtracking is basically another form of recursion. However, unlike depth first search, where we may have the same number just in different patterns, let's make sure that we have a unique set, right? It goes all the way down and then goes back up. And the majority of this was just normal recursion. This is the backtracking method over here. And yeah.